Hello everyone, and welcome to a video for Ticker version 2.03 beta. There's been a lot of changes since the last release. Most of them are code-wise changes, so you won't see specific buttons and options changed. In this video, we'll be talking about the anchor escapement, what you can see swinging on the screen here. The reason I've chosen the anchor as a tutorial for how to use Ticker is that the anchor is a very versatile escapement. If you're going to be doing some kinetic art or you want to design your first clock, you could do worse than to choose a recoil escapement such as the anchor. It's pretty obvious why it's called an anchor escapement. It looks like an anchor hanging upside down, the way the pallets work. We're soon going to be into the 400th anniversary or so of the invention of the anchor, and it superseded the verge escapement, which was found to be too inaccurate. The anchor escapement is much more accurate, and it was about the time of the invention of the anchor that they discovered that the less a pendulum swings, the more accurate the timepiece. And so the anchor was their first replacement for the verge, and would a few years later be replaced by a deadbeat, which, although it's slightly more efficient and accurate, is also somewhat more finicky to get running. One good thing about the anchor escapement is it's a very easy escapement to get running, and I thought a tutorial on how to build such a device might be a useful way to see the way the workflow works within Ticker to make an escapement. Before we begin to draw an anchor escapement, I'd like to point out one of the changes with version 2.03b can be seen by the two white gears in the center of the screen. You'll notice that their teeth are staying properly in synchronicity as two gears should. This was not true of any previous version of Ticker. It was possible if the masses of the various sides of the gear equation were imbalanced to a certain extent, the gears would slowly go out of synchronicity. I left this until the end of most of the work on the various force interactions to fix, and I'm happy to report it has been fixed as of this version, with the exception, I believe, of worm gears. Those are next to be resynchronized. This was done by adding an additional constraint into the constraint system to try to make sure that all gears stay lined up. I just thought I'd mention that in case anybody had noticed that the gears were not staying synchronized throughout their run. So we're going to start a fresh project. I'm going to first start by clicking on the face to make sure that we're looking straight into our work table. Then I'm going to flick to SimCAD. In SimCAD lies a new button, Recoil Escapement, which will make this video so much easier than what it looks at the very beginning. When you click Recoil Escapement, you'll be given a dialog asking you the various variables that you require to make an anchor escapement. Pressing preview will put a base escapement on the screen. Now you can continue to change that escapement, entering new teeth numbers, for example, or different tooth spans. And it's worth talking about why you would choose various numbers here for a moment, if we can diverge from how you use the program to how you design a clock escapement. Anchor escapements are commonly driven by a 1-second pendulum. They don't have to be. You can certainly design any number of teeth you want to correspond to different pendulum lengths. However, it's not unusual at all for an anchor to be driven by a 1-meter long pendulum, and that gives it 1 second per beat. Now, an escapement such as an anchor releases a half a tooth per beat. So if you have a 1-second beat and a 30-tooth wheel, you will get this ratchet turning once for every minute, and that allows you to use the center axle of this ratchet as a second hand. Now, if you're not designing a clock that you want a second hand, it wouldn't be unusual to use, for example, 36 teeth. And thus you would only need 10-to-1 and 10-to-1 again in two different ratios to get minutes hand and an hour hand functioning properly. So really, how many teeth you select at the beginning of an escapement such as this is determined really by the length of your pendulum and by whether or not you want to have a second hand on the clock. Now I'm going to select 30 teeth on this escapement because this will allow me with a 1-meter pendulum to have a second hand, and we'll deal with the ratios afterwards for that. Other things that you can select on this screen, the tip radius will set the overall size of your escapement. You might as well in reality set it to a size that you're comfortable with drawing with, because you can, in the end, if you wish, shrink it down and scale it down. Once designed, an anchor escapement is fully scalable. The tooth span here, I've got set to 5.5 teeth. You can set this tooth span to whatever you wish. However, the lower the number of teeth that are spanning, the higher the pallet axle will be away from your ratchet. And generally, a person will pick a span which allows for the best looking balance between the pallet wheel and the ratchet. If, for example, I take it down to 3 teeth and re-preview it, you can see that the pallet gets closer to the ratchet and we get very fine looking lifting teeth on the pallet. This makes it very hard to build, or much harder to build than if you use a wider span. If we go to 5 and hit preview, you can see that we go to a much more balanced look. And we can take it up even higher, say to 7, but you can see now that the pallet is beginning to look a little large compared to the ratchet. Nothing wrong with that. It could be part of your design. However, for myself, I've chosen 5 to be a good looking balance between ratchet and pallet. And so I'll deal with it from there. Once you've set all of these items, tooth tip is set for the tip of your tooth. Some CNC systems, if you're cutting one of these out of wood or something, you don't want too sharp a point here. It can make it very hard for you to make it where it won't snap off. This all depends on what you're using to cut. If you're 3D printing, you're probably fine with a 1/2 degree tooth tip. You may want to use more, however, if you have construction issues. The drop angle here is another one which is important. The clock is actually more accurate the lower the drop angle. However, it's also harder to make. I recommend at least 1.5 drop angle for most people to build either a wooden piece or a piece that you don't want to be finicking with when you're trying to get it running. Some of these escapements can be very finicky. This is one of the settings, the drop angle, that makes it finicky. So if you keep it at 1.5 degrees or above, normally these things will start ticking the second you swing your pendulum. The other important number here is the pendulum angle. This is not something you set. When you change the number of teeth and various other variables, this is a calculated variable from those. And it's simply something for you to remember. If once you've generated your escapement and you're happy with your settings, remember that your pendulum angle is 2 degrees. Because in order to draw a pendulum, you will quite literally draw your pendulum off of this center circle out at 2 degrees as a start position for your pendulum, and that'll allow it to start ticking instantly when you start your simulation. We'll go over that when we get to the point that we draw a pendulum. Another thing that you might want to worry about is which direction your escapement is going to turn. This particular escapement is set to turn clockwise. This tooth here is pushing up on this pallet and is just about to start pushing it. So our pendulum at the moment is sitting over here somewhere where my mouse is. You may want this pendulum to go counterclockwise. You normally wouldn't do that if you have a second hand, but if you don't have a second hand, having it go counterclockwise at the start can save you an extra gear in the gear train, which you would have required to reverse the direction of your minute and hour hand. So if you want it to go in the opposite direction, create your raw anchor escapement, select it all, and select mirror. And if you tell it to mirror to the side, you now have an escapement that goes the other direction. I'll mirror that back because we're going to use a second hand, which means I want it to go clockwise. Now the first thing I'll do when I'm looking at something like this is I will decorate the ratchet. If I just extrude this ratchet, it will be a flat disc that I cannot see through. And if I can't see through it, I can't pick other gears behind if they should be hidden behind it. So the first thing I'm going to do is, in this case, just draw a circle, not too large, right there above it, and then select the check mark to turn off my selection. Then by clicking on the circle, I can select it, I can select circular array, and set it for 4 copies over a sweep angle of 360 degrees. And now my palette is somewhat decorated so that I can at least see through it once it's been extruded. You'll find that that's important when you're trying to deal with the design later. You could, of course, draw any sorts of slots or spoke design you wish in here. I'm simply doing this for the sake of brevity. It's quick and it allows us to see through it. Once we have our decorations done, we want to select our center shaft. And up here on the far right, we want to click the Set Unset Shaft so that it's green. And that means our ratchet is now ready to go. I can select it simply by dragging a box around everything except the pallets. And then I can hit the extrude button. And we'll extrude that to 5 millimeters deep, just because I tend to do everything in 5 millimeter increments. And now for this wheel, because it's got so many teeth, you may find that you need more hulls. Another change that has been made with Beta 2.3 is that the hull generation is much quicker and much more accurate generally. So I'm going to move this up to 128 maximum hulls, just because we have so many teeth that I'd like to have clean teeth in order to activate our pallets. Normally I would leave this low just for the sake of speed in the simulation. I'll hit the Generate Hull button. You can see it very quickly generated our convex hulls, and we don't see any strange lines around our teeth. That looks pretty good. So I'm going to say Complete Object Creation. And now before I click anywhere on the screen, which would move my gear, I'm going to hit Accept, which puts our gear on the screen, and the screen that we're on now is simply Z height. And I'm going to click in the Z and enter 40, just as an arbitrary number, but an even number so that I can match things up later on. And with that being done, I can hit Accept, and we now have our ratchet on the screen. Now before I go back to Sim, I'm going to click on the face to make sure that we're looking straight into the screen, so that on our SimCAD screen, when I turn on Blueprint, I can see where our originating ratchet is. Well, now that we have a ratchet, we need the pallet. So I'm going to click on the shaft of the pallet, and again set it as a shaft so that the icon turns green. I can then select all the things in our pallet and ask it to extrude. It'll extrude it to 5 millimeters. And now we need to generate a hull. Now on this particular, because it's a pallet, we have two important surfaces. This curve at the bottom of this tooth and this curve on the right hand side. These are important sliding surfaces for the teeth of the ratchet to slide over. And because of that, I want to be very picky on my convex hulls here. So I'm going to click with Control pressed into Max Hulls, and I'm going to type 300 as a maximum hull to be generated and ask it to generate. We can see up here it actually found 283 hulls, which would efficiently do it, and indeed everything looks to be very well covered. So I will complete object creation. And if I zoom out with my mouse, again without clicking, if I click, that palette will be repositioned from where we drew it. So I don't want to click anywhere on the screen. I'm going to hit Accept, which now puts us on our Z screen. And as you'll remember from before, I had this set to 40 degrees, to 40 above, I believe. So we'll move that up to 40. And if we look sideways, we can see that we're lined up. So that's a perfectly good spot. We'll accept that. And now we have our escapement base sitting on the screen. Now we have to animate it and add a pendulum. So there's a couple things to be concerned with. First of all, if we're going to force any of these objects to be oriented towards us and not be spun around by forces, we need to have something else on their shaft. Luckily for us, we need something on these shafts anyway. So let's design a button to go over the front of this pallet, for example, to hold it in place. We'll start by clicking on the face to make sure we're looking straight in, and we'll go to our SimCAD screen. We can now see where our pallet is. And what we can do is draw a circle to act as a cap. And you can see when I hover my mouse, I'll get a CC on the screen when I'm at the center of that hole that was already in that shaft. And I'm just going to drag this fairly large to about there. To about there. I'll right click and use my check to turn off my tool. And now if I select this center shaft that we use to draw the pallets, we can see it's still lit up as a shaft. So that's good. I'll select the outer circle that we just drew. And now we'll just extrude that. And I'm only going to extrude that to, say, 2 millimeters thick, because we're going to use that as a holding ring. We'll accept it. We can set our max hulls back down to 64 as a default for ourselves. and hit Generate Hull. There's our hull. We'll complete. And now we have to decide where to put this object. You can see it placed it on the screen in line with the shaft. It doesn't know that it has to be on the shaft, but it does know the approximate position, and that's where it will initially place it. In our case, we want to click on the shaft itself, which will allow us to slide this object up and down that shaft. I'm going to turn the object sideways with my mouse and slide this down so it's just above the pallet, and we'll accept that. Now that we have a shaft with two objects on it, we can click on this object we just put on and tell it we want to lock orientation. And in fact, we can go to expert mode and give it a bit of mass. So it's got a bit more mass than most things on the screen, and it's holding a shaft which should hold that pallet nicely and allow it to spin. Now we need something on our ratchet. So I'm going to put a gear on our ratchet, because in the end you're always going to want to have a weight train transferring energy to your ratchet. So rather than draw the entire complicated weight train, we'll start with the gear that we would normally pick. So I'll go to spur gears, because you normally drive a weight train with involute gears, not with cycloid gears. And you want a small number of teeth, as small as what you figure you can get away with to drive your escapement wheel. This is because you're trying to get as much time as you can out of whatever weight train you're putting on. So you'll normally have a small gear on the weight train side of your ratchet. So I will create that pinion. I will click on the shaft of the ratchet, and I'm going to put it directly behind the ratchet. Now you have to be careful that you're not touching the ratchet, or you could create a collision problem. So I'm going to make sure that I get a little gap there between the two of them, and then I'll accept it. And now that gear that's in behind, you can see I can select it through the hole on the gear, and this is why I recommend decorating your gears. If that hole wasn't there, I wouldn't be able to select that gear. So it's handy to have some decoration on your gears. So I'll select that gear, and I'm going to tell it to orientation lock as well. I'm also going to give it a motor, tell it to go clockwise because we want our escapement to go clockwise. I'm going to turn off the ramp time because we don't really need any ramp to it. And I'm going to turn our force down to maybe 100,000 or so, just so that we're not pressing too hard on our escapement. At this point, we can really hit go on the simulation just to see what would happen. And what happens is very much what happens when you start playing with one of these escapements at home if you don't have a pendulum and you don't have things properly set up. Here what's happening is, if I hit it run again, if I tilt this to the side, you can see that our motorized gear is moving, but the ratchet is not matching. We haven't locked the ratchet to the shaft. So if we click on our ratchet, you can see there's a shaft lock here. We lock the grub screw for it. And now when we tell it to run, it does exactly what you get at home. It ratchets. It toggles back and forth very quickly. There's no gravity or pendulum to slow it down, but it's operating exactly as you would want an anchor escapement to run should you not have a pendulum on it. So that's the next thing that we really need to add is a pendulum. Now to do a pendulum on a real anchor escapement, you would normally use what's called a crutch. A rod would come off of this axle and come downwards perhaps to the bottom of the ratchet area. And it would have a little rod on either side of it, and the pendulum would ride from this shaft down through the center of the crutch. The pendulum would not hang from this shaft, but instead would hang from a bit of spring above it so that the bendy point of the spring is in line with the shaft. The crutch would then push the pendulum back and forth on its own independent held spring. This allows for a higher efficiency of force transfer and will make your clock run longer. However, for a simulation such as this one, we'll just simply draw a pendulum and add the pendulum to the shaft, which also works, but it's simply less efficient. So I'll again go back to 3D models, click on the front face, and go to SimCAD, and now we can see that all the parts that we had put on so far are properly laid out for us. To move your drawing around, by the way, such as this, you simply right-click your mouse. It's a very quick way of getting in with your scroll wheel to zoom in, and I think you'll find that in terms of manipulating the drawing, it's very quick. Now, if you'll remember, when we designed this pendulum originally, we were told that it was a 2-degree pendulum swing. And that's where this becomes important now, is we want to add a pendulum at 2 degrees. So to do that, I'm just going to select on lines. I'm going to select the center of the pallet shaft, and I'm going to draw a line at 2 degrees from straight down. Straight down, of course, is 90. So I'm going to set this at -88. I can do that by hitting the tab key so that the degrees is highlighted in blue. I'll type -88 and hit enter. And now I'm locked at that angle, but I can drag it to any length I wish. And I'm going to drag it all the way down to, say, 500, just for the sake of this experiment. We'll make it a ½ meter long. I'll turn off that line tool, and I will select just the line and ask it to offset that contour, and we'll go with 4 millimeters on either side of the contour, and we end up with what looks like a long narrow rod. I'm going to put a bob on the end of it. We'll just click a circle here, drag a bob out, right click, turn off our circle tool, and now we'll go to our trimming tool, and we will just trim away the unnecessary parts of this which don't look like a pendulum. Obviously, these lines that we drew that intersect with other objects will have to be taken out separately. Remember that Control-Z will undo something if you do something that you shouldn't have done. And we'll click this away. And there is our pendulum. Now we'll again reuse that shaft hole that we were using before. Click on it because we can see that it's still lit up in green as a shaft. And we will press the Shift key so that we can select more than one contour and click on the rest of the pendulum. We'll then extrude that. Let's give that a 5 millimeter extrusion as well. And now we need to generate a hull. It's very quick to generate a hull. And now we can place it, and you can see it's already placed it in the approximate area of our pallet axle. And it's hanging down so far we can't see it. So I need to click on the axle itself and move the pendulum down to a point where it doesn't hit the gears that are in behind. So I'm going to move that down to there. That actually looks a bit close to our tabletop. Oh, it is above it, so we will, maybe I'll try to just make that move a little bit further up. I'm finding that the axle positioning is a little gritty. I'm going to have to take a look at why that is so, and we'll accept that. Now the other important thing here is that our pallet is locked to its shaft, which it isn't at the moment, and that the object that we just placed on the screen is unlocked in position lock and is set on its shaft lock, and we'll lock it to there. And now when we start the escapement running, we should see a different time on our swing. And there's our escapement ticking away, and it doesn't seem that it wants to stop. Now when we run this, we can see that it doesn't seem to be the right speed, and if I change gravity, the speed doesn't really change. And that means it's not really running as an escapement. And the reason for that is that we didn't put a center of mass on our pendulum. Any pendulum needs a center of mass on it because in Ticker, the center of mass of an object is where you placed it. In this case, way up here on the pendulum. So I'm going to stop this for a second, go to 3D models and hit mass center. When you click on mass center, you're then expected to simply click on an object to set its center. And I just dropped one onto the shaft. And I don't know if you can see it, but a little center of mass appears. And a slider up here whenever you select it so that you can set the mass which is on that point. The mass of a pendulum is not important, only where it is. So we're just going to leave that at a mass of 1. And let's try making it tick now and see what it does. Now we can see it's bouncing around a little bit.
but it is running properly. So in order to stop the bouncing, I'm going to put an orientation lock on that, because it does have other things on its shaft, so it's safe to do so. And we can see that now everything straightens out. We can also see that the time seems more stable, and if I move gravity down, we can see that it slows down with gravity. And this means that this escapement is running under the force of gravity, not by having the ratchet simply drive it with force. Turn our gravity back up to full gravity, and we can see that we have approximately a 1 second swing. I don't believe that's correct, because with a 500 millimeter pendulum, we should be going faster than a second. This should probably be somewhere around 0.8 of a second or something. So if you did put a 1 meter pendulum on here, though, this is a clock which would become your basic grandfather clock. It will turn once per minute, very stable, very easy to get running, and as you can see here, it's near idiot proof in terms of making it run. I've taken us back to the SimCAD screen just to point out a couple of things I may have neglected before. When the escapement is generated, the shaft hole sizes that are generated are arbitrary. They probably don't match what you're going to want. But for any circle which is generated on a drawing, or indeed for one that you've drawn yourself, if you select it and then select the drawing tool, you'll be given statistics on the circle and a chance to modify it. So if, like in this example, I want a 5 millimeter shaft, the program created a 4.81 millimeter for some reason algorithmically. So I'm going to enter 5 and OK, and you can see that the circle changes diameter. So before you create your escapement initially, you're going to want to just check your shaft hole sizes and change them to the proper size. It's easy to do because you only need to select the circle itself and press the circle tool in order to get a modification. Beyond that, the other thing worth mentioning is that for the pallet itself, I'm going to turn off Blueprint for a moment so we can see it more clearly. For the pallet itself, the only important part is this curve and its back tooth, and this curve and its back tooth. Everything else you're free to modify as you wish. You can draw other shapes and use your trim tool to personalize your pallets to be whatever shapes you like. That, I think, is all that needs to be said on how to get an anchor escapement running. I hope you enjoyed playing with the program. Have fun.